Assalamualaikum and hi everyone. My name is Muhammad Akmal Haikal bin Azhar, PC24138. Okay, for the introduction, industrial operation really heavily on equipment such as motors, pumps, compressors, and processing machine that generate continuous heat during operation. To ensure safe and efficient performance, this equipment must operate within controlled temperature limits as excessive heat can lead to overheating, equipment failure, and production delays. This project presents a complete engineering project carried out of Cemnergy Enterprise, Sdn Bhd, a Malaysian water treatment company established in 2001. The project focused on installation and optimization of a cooling tower system integrated with a structured water treatment program. The main objective of the project is to stabilize circulating water temperature, protect equipment from corrosion, scaling, and biological fouling, and enhance overall system performance and operational reliability. Okay, for this slide, I will tell about a project background. Moving on the project background, the three critical issues were identified. The first one is heat accumulation, which caused motors and compressors to shut down or consume excessive electricity. Second one is the consequences of heat accumulation, including a higher risk of equipment failure, increased downtime, and higher maintenance costs. For the last one is a poor water quality, where mineral scaling and algae growth degrade system performance. Addressing this issue is essential to ensure operational efficiency.
Moving on to the methodology behind our report. To ensure our finding were both accurate and practical, we utilize a combination of primary and secondary research. For our primary data, we conduct a physical site visit to witness the cooling tower operational condition and physical constraint firsthand. This was followed by an in-depth 2.5-hour interview on December 23rd with Chemnergy's site engineer and assistant engineer, who provide us with invaluable technical insight. To complement this, we gather secondary data by researching corporate website and technical publication, allowing us to benchmark this specific project against industry standard for a more comprehensive analysis. Every project has its hurdles, and this one was no exception. We structured our analysis around the 5 standard phases. The first one is initiation, planning, execution, monitoring, and the last one is closure. During the initiation phases, our biggest challenge was a lack of detailed technical data from the client. We overcame this by conducting specialized meeting and performing manual site measurement. In planning, we anticipated potential material shortage, so we proactively identified backup suppliers to prevent delays. Finally, during the execution phases, we encountered equipment alignment issues and unpredictable weather. However, through immediate troubleshooting and strategic rescheduling, we managed to minimize any negative impact on the project timeline.
Finally, during the execution phase, we encountered equipment alignment issues and unpredictable weather. However, through immediate troubleshooting and strategic rescheduling, we managed to minimize any negative impact on the project timeline. During the monitoring phase, we tracked the water temperature for 1 month, including circulation rates and bacterial activity, before the operator training conducted sessions so staff could perform routine tests after project completion. On the last phase, a formal handover after confirming the system met all performance expectations was the closure.
Now, let's discuss the results. Overall, the project was successful based on two main results. First, in terms of system performance, the new cooling tower worked well. It was stable in control the water temperature and solved the previous overheating problem. For the second one, for the water quality, the chemical treatment program was effective. It reduced scale build-up, corrosion, and biological growth. In conclusion, the project achieved all its objectives. The cooling system is now stable, efficient, and suitable for long-term use at the facility. Next is 4.0 Key Challenges and Solutions. During this project, we faced two main challenges. The first is lack of the technical data. Some initial information from the client was missing, which made the design process difficult. To solve the problem, we carry out manual measurements at the site. This helped us get accurate data and complete the design correctly. For the second one is relate to logistic and supply chain. There was a risk of delay in getting good quality cooling tower components. To overcome this, we prepared backup supply. This ensured that the project timeline was not affected.
To improve future engineering projects and system reliability, the following measures are proposed. First, early data collection. Capture all equipment, specifications, and site constraints thoroughly before starting design work. Second is system automation. Implement automated chemical dosing using online sensors such as pH and conductivity to minimize human error. Lastly is advanced monitoring. Utilize vibration and temperature sensors to provide continuous monitoring for all rotating equipment. The project utilized several key tools and methodologies to ensure effective delivery and team transparency. Number one is scheduling. Microsoft Project or Smart Sheets were identified as essential for creating and managing Gantt charts. Number two is collaboration. The team maintained transparency through structured meetings and the use of shared digital documentation. While lastly is reporting. Digital systems were used to record and analyze operational data collected from the control panel. To conclude, this project has successfully demonstrated the effective planning, implementation, and management of a cooling tower system within an industrial environment. By integrating a structured water treatment program, we were able to achieve our primary objectives, such as stabilizing circulating water temperatures, enhancing cooling efficiency, and protecting critical equipment from thermal stress, corrosion, and biological fouling. Despite facing several operational challenges, the system was delivered successfully by following a rigorous project life cycle covering initiation, planning, execution, and formal project closure. Our experience proves that early data capture, timely monitoring, and the correct integration of engineering solutions are essential for long-term system reliability. We believe the outcome of this project will serve as a valuable reference for future cooling tower installations and similar engineering endeavor. Thank you for your attention.